Good day. I'm William Garvey, the host of Plane Talk on Wingspan News. It is a very real pleasure to welcome George Bai to today's program. Mr. Bai is the founder, CEO, chairman of Bai Aerospace based in Englewood, Colorado. He's not only an air transport rated pilot with some 4,000 flight hours logged, he is a pioneer, a true pioneer in electric aviation. He is the innovator behind the E family of electric-powered general aviation aircraft. He's an engineering graduate of the University of Washington. He went on to become a U.S. Air Force pilot, flying both the C-141 four-engine transport, as well as the T-38 twin-jet trainer, in which, by the way, he was a senior instructor, and that role has benefited him certainly in uniform and out. And then after leaving the service in 1993, George went on to imagine and develop a series of unusual, even unorthodox aircraft called the Javelin. Your enthusiasm for those kinds of aircraft, or unusual or breakthrough aircraft, never diminished. Did you learn lessons from that that have helped you in these follow-on projects?
You pioneer something new. Of course, the Javelin was meant to be an advanced trainer and a high-end, high-performance, very light jet. Those kinds of characteristics, carried on into the future with other programs that we help support at Boeing and so forth. And the legacy of that technology still today is very much in play. We transitioned, as you pointed out, into electric and solar electric, single seat, multi-seat. And then as the technology matured, began to look at product market fit. The initial point, of course, was the two-seat trainer. Again, something I'm very, very familiar with. The inspiration kind of came from the EV markets emerging over that same time frame, the 2009, 2015 timeframe. Oh my gosh, the technology roadmap, the solid line to dashed line to cut, that white space that we like to talk about. That's cool.
When you first focused on electric propulsion for aviation, there really was no such thing. Was there any precedent at all? And,
No.
And what was the year? Was it 2009?
Yeah, it really was, and you and I talked back in those days, electric and solar electric in a very, very long wing, high aspect ratio, L/D, lift to drag ratio, aero efficiency for those in the audience, was necessary because the battery energy density was very slight, very low in comparison to where we are today, and of course where we're forecast for tomorrow. But with a very efficient wing and the emerging thin film solar, we looked initially at autonomous and piloted, call it electric gliders or solar electric gliders for various kinds of applications. And as the battery technology continued to progress, began to experiment with the possibility of an electric trainer.
Trying to solve a lot of the propulsion and battery-powered obstacles, if you will, with solar panels on the wings, solar panel on top of the fuselage behind the cockpit, and I guess on the stabilizer as well. I'm trying to remember. And then the idea was, even if that didn't supply enough power or length of power, I guess, density, that once you landed, you could pull the battery out and put in a new battery. And all of that made sense, but not as much sense as just going with a straight battery and recharging it. That wasn't available at the time, but it became available.
The plug-in option just wasn't even imagined yet. Tesla hadn't really emerged yet. You saw the first, second, third generation of Toyota Prius hybrids. Some of the imagination of the possibilities of how solar and electric might be used. And of course, as technology matured, we saw the first inkling, the first possibility that a plug-in solution might be possible, which would which would really increase market acceptance. It wouldn't be kind of a unique special application, but potentially a broad application.
Is there a future for solar in aviation in some capacity?
Oh, absolutely. The efficiency of the solar conversion has continued to increase. The thin film and the ability to adhere the thin film to the top of a composite surface has improved in terms of technology and the readiness to do that. Perhaps most importantly, the cost has come down. So various types of solar electric patrol aircraft are imagined. And those kinds of missions where long endurance patrol, particularly daylight patrol, coastal patrol, pipeline patrol, oh my gosh, government and defense, of course, come to mind. You can imagine those applications are very much possible. Now, for today, our focus is the emerging and urgent demand for pilot training. And an all-electric eFlyer 2 solution, of course, 1/5 the operating cost as compared to a legacy Cessna or Piper. That's a driving urgent demand and a compelling disruptive opportunity from a business case. This is pioneering an entirely new roadmap to a Part 23 aircraft, likely the world's first certified electric airplane under the level 1 criteria. So important. We need to get the bow around that package and get that delivered. There are a number of great fleet operators, pilot training academies around the world that are anxiously awaiting that new product. And our job, our focus right now has got to be to execute to that first milestone.
How much potential is there? What's the urgency?
Boeing and Airbus are forecasting a 20-year requirement for commercial pilots, airline transport pilots. That's a 5-fold increase over where we are today. Imagine a year or 2 or 3 down the road, the economy is robust. We're traveling internationally again, and the pilot shortage that's been discussed and maybe having minor impacts in the last few years now becomes an urgent requirement. Our trainers today, great trainers, Cessnas, Pipers, and so forth, are going to be pressed into service to the maximum, and likely not really the robust solution going into the future, and it's certainly not in the numbers that are needed.
If the need is so urgent, couldn't Cessna and Piper just crank it up along with Diamond and the others that are making trainers?
Our friends at Textron Cessna, and of course Piper, which has undergone a little bit of a transition, and of course Diamond has also, certainly are producing today's trainers in a conventional sense, whether it's a diesel jet fuel or a high octane avgas, but in very small numbers. And of course, it's not paradigm changing in terms of operating cost. If anything, we're seeing fuel costs continue to go up.
Yeah.
So the replacement of the legacy fleets is about 11,000 units or so, according to the FAA. About 11,000 units are identified in the FAA registry as trainers. Of course, as we know, most of those are Cessna 172, Cessna 172s, Piper Archers, Cessna 172s, by and large. However, they average nearly 50 years of age. Yeah. 50 years of age. So tomorrow's pilot is being trained on yesterday's airplane, and great airplanes. Oh my gosh, what wonderful, amazing airplanes to be in service for 50 some years.
Yep.
Wow. And yet it's time. It's really time. And when you can reduce the operating cost to 1/5 of the cost of a Cessna or a Piper, that breakthrough benefit is passed along to the fleet operators, to the flight schools.
And the thing you haven't mentioned, but we know it's out there, is it's not burning avgas, it's not got CO2, it's not releasing lead into the atmosphere. Those are good things, and they're quiet.
It's about 1,000-fold or 30 decibels quieter in our flight test operations over the last 3 or 4 years. Literally, I could stand on the taxiway about 500 feet away, and depending on wind direction, you couldn't even hear it. You couldn't detect it. It's such a dramatic change. And of course, most of our airports, over 50%, are located in high density urban environments. So it's not just CO2, climate change and fuel combustion byproducts. It's also noise. It matters. And a lot of our friends in Europe, it really matters.
The big challenge now is regulatory. As you've said, it's under FAR 23, but it's a special amendment within FAR 23. So you're not only creating the airplane, you're helping create the rules, right?
You know, you're absolutely right. We are working right alongside our friends at the FAA. Every single day, there are discussions around how we approach this particular aspect or that, of course, with safety as the overarching criteria. But it has not been done before. Okay. And as motivated as we all are to the outcome, the process along the way is a process of discovery and looking at things that haven't been thought of previously as the primary propulsion unit. And by that, of course, it's a system of systems, you know, battery cells, modules, battery management system, controller, motor, propeller, etc. All of which are kind of common sense in a conversation, but when you get into the details, the technology and the process of showing and demonstrating in test results and flight results, ultimately in flight test, is immense.
Is there a technology barrier at the moment, or is it all working and you're satisfied with what you've got?
Technology barriers are opportunities when you're an entrepreneur, right? And what we study as entrepreneurs, we study our fellow pioneers in their technology silos. You know, battery cells is a technology silo, but it's driven by a tidal wave of market forces that are a lot bigger than by aerospace. Now, I've talked to specific cell providers, even two of them, even this week. One in Europe, one here in the U.S. And oh my gosh, are they driving cutting edge? I mean, we're looking at 400 to 450 watt hours per kilogram, rather than a critical technology that would prevent us from achieving the outcome. As you say, a barrier. It certainly is an opportunity, and one that has to achieve the highest credentials, meaning safety in aerospace. But the backdrop of that critical technology is surprisingly broad and deep.
It's got to be a little frustrating, though, because at some point you got to say, this is what it's going to be. Even though the technology is advancing, you got to stop at some point and say, we want to certify this.
You're absolutely correct. And what's interesting about that is, as you have schedule creep and other components and processes that move the schedule to the right, there's that trade of, well, do we pause here, or do we allow this next generation to come in and get another increment of benefit? And by the way, I would add another increment of safety. The systems architecture, the layout, if you will, embraces all of the technology that we've already outlined with the FAA. We've got 16 of 16 system-specific certification plans submitted to the FAA, all of them. 16 of 16. Each of those, of course, are intellectual property. They're an asset to the company, but they describe in detail all the critical features of the E-Flyer 2. It's merely an iteration,
Right.
a modification to each of those 16 features, et cetera, to create the E-Flyer 4. So it's not a start from scratch. It literally is an evolution to a slightly larger airplane. Of course, a very robust four-seater, 150 kilowatt hour battery pack instead of 75, but the same module, BMS, motor philosophy, layouts, the structure, aerodynamics, the arrangement, if you will, of the airplane. Very much a family of aircraft.
Will they share a type certificate at all, or they'll?
No. Great point. It will be certainly a new type certificate. The level 1 aircraft going to a level 2 aircraft with a 4-seat arrangement does pull in a different set of criteria, at least in theory, under the new Amendment 64. Again, sharing the architecture, Safran's our motor provider, well advanced in E-Flyer 2 motor testing. We just, in fact, motor testing underway right now for their certification. The propeller bird strike test was just successful. We're moving ahead. The ASR parachute test, first test was successful. We have a full airplane parachute. All of those kind of features and partnerships focus today on the 2, making ready for the 4 tomorrow, and then not too far down the road, again, that same kind of philosophy of borrowing and leaning forward to the future will benefit the E-Flyer 800 as well. As you know, Garmin's a great partner and friend for the E-Flyer 2, and have really marvelous technology in their auto return to safety system.
It's miraculous. It's just technologically miraculous.
So, we have to look at emerging technologies from Garmin and others in terms of safety systems on the E-Flyer 800, but all electric safety, all electric redundancy, no CO2, high speed, high altitude, and safety all the way through this brand new twin turboprop equivalent.
Can you give me a sense of the pricing of the different airplanes, and what's the order book look like?
As much as I am honored and proud to be leading this team, the bottom line is the market. Mm-hmm. And from around the world, from Norway to Denmark, UK, across the continental Europe to Canada, US, Australia, and Asia, we have very nearly 900 units in our production backlog. 884 as of this date. Of course, that'll change literally as we look ahead here in the days coming. But we are just so encouraged by the market response. Paid purchase deposits on the future of aviation. The all-electric E-Flyer 2 is about half of those units. E-Flyer 4, another maybe 30% or so. And even though we just announced the E-Flyer 800 a few months ago, several customers on the E-Flyer 800 and 135 units in backlog for the E-Flyer 800 even.
Wow. Wow.
Now, a smaller portion of those are paid purchase deposits. A larger portion of those are paid option agreements. But as you would expect, because it's 5 years out. Yeah. But just a tremendous demand and desire for the future.
Can you give me approximate prices on? I know it varies.
Yeah. So the 500,000 to 600,000 range, again, typical for a trainer, again, like the Cessna or the Piper or the Diamond. for the E-Flyer 2, 700 to 800 range for the E-Flyer 4, again, typical for the larger 4-seat, Cessna 182, Cirrus SR20, and so forth,
Okay.
Diamond Products and others. And then $5.4 million price point for the E-Flyer 800, again, 8-seat turboprop, 35,000 feet, 500 nautical mile, and very, very aero efficient in each case. Kind of interesting, allows a much higher speed at a lower energy cost. We don't have that parasite drag from the front plate flat area and the cooling drag required, typical to a piston engine airplane, or the scoops and such needed for air combustion. But we deliberately have gone purpose-built because there's such an advantage with a clean sheet design from the drag perspective, the aero efficiency. A Cessna 172, about a 9.6 L/D. We're over 20 with the E-Flyer 2. Wow. So twice the aero efficiency. So incredible advantage to a purpose-built airplane. Of course, there's more effort, more cost, for sure. There's a lot of discussion around electric aviation.
Yeah, there is.
And of course, you have covered so much of it so well for so many years. And thank you. And I'm honored today, by the way, to be with you. I really respect you and appreciate your time and speaking to us today. But one thing I would like to just briefly touch on is the difference in electric aviation between an eVTOL and a conventional fixed wing airplane.
Okay.
And a lot of excitement around eVTOL, and a lot of people in the market kind of blend us all together as just electric aviation. But an electric helicopter or rotorcraft is suspended in the air directly by the thrust driving down from the propeller or rotors. And the advantage of electric fixed wing aircraft, of course, is that we're suspended in air by our wings.
Right.
And so the great benefit, the access to market is well known with a fixed wing conventional aircraft. Propulsion system's different, but the process of a legacy or conventional aircraft coming to market is much better understood with markets that are traditional. Mm-hmm. What electric aviation does better is bring that operating cost down with all of the benefits, of course, to the climate with no CO2 and very little noise. So just a moment to kind of contrast significant difference in configuration in the urban air mobility market space and airspace and regulatory environment, as opposed to a conventional fixed wing, which has an immediate and urgent demand in a market that's well understood.
Your products have generated already is staggering. Honestly, it's just staggering. I'm not sure there's ever been a launch like it. Has there been?
I would be hard pressed to find equivalent market response. It may be a whole new paradigm of acceptance, especially at this point in development. And again, that's a great honor and also a great responsibility, because those are wonderful people that are looking forward to all the benefits of electric, and our job is to make sure we get them those airplanes.
Well, the best of luck in doing that. You've done extraordinarily well so far, and I expect to see these. Unlike a Javelin, I'll actually get to fly.
Absolutely. Absolutely. You will. You will.
Thank you, George. Thank you indeed.
Our pleasure.
We've been speaking with George Bai, the founder, the chairman, the CEO of Bai Aerospace in Colorado. He's a pioneer. The company is a pioneering company in electric aviation, and the responses have been terrific. I'm William Garvey, the host of Plane Talk on Wingspan News. Thank you for your time. Thank you for your interest, and best of luck to you all. Bye now.